Greetings. I'm Diana Farmer. I am a fetal surgeon and a scientist, and I am here today to tell you about some amazing discoveries that we have made with the help of CIRM, our California Stem Cell Agency. So, what is fetal surgery? Fetal surgery is that area of medicine where we take care of babies in the womb. We take care of babies before birth. And if you think about 60 years ago, when your parents or your grandparents were born, they really had no idea whether they were going to have a boy or a girl, whether the baby was going to be okay. What did they do? They counted fingers and toes. But then along came an amazing technology called ultrasound, where we could look inside and see problems in babies before birth. So we've been treating babies before birth now for many years, but only recently have we started thinking about babies who weren't going to die, but just have some serious disability. And that's when I got interested in spina bifida. So what is spina bifida? Spina bifida, first of all, is one of the most common birth defects, even if you haven't heard about it. The good news is most babies don't have any birth defects. They're completely normal. But occasionally, something doesn't go right. And in this case, 4 children every day in the United States, and even more in other parts of the world, are born with a condition where the spinal cord does not close normally. In normal development, the spine closes over the spinal cord and the baby's back is completely closed and the spinal cord is protected. But in spina bifida, that fails to occur and that spinal cord is exposed in utero. That means it's exposed to all the amniotic fluid and it can bump up against the side of the uterus. It just has a lot of trauma during gestation. And the result of that is that when the babies are born, they're paralyzed. For years, it was thought there was nothing that could be done until we asked the question, what if we operated before birth and protected that spinal cord during the rest of gestation? Could we make it better? And that's what you see in the lower column there. I apologize for it being a surgical picture if you haven't seen one of these before, but that is the back of a fetus in utero being operated on to close that defect. So we did a fancy study called the MOMS trial, the Management of Myelomeningocele, in the early 2000s that asked that question. If we operated on children before birth, did they have a better outcome than the children that got operated on after birth? And lo and behold, what we discovered was that indeed this was true. That the babies who were operated on before birth, for the first time ever, had a better neurologic outcome. They were able to move their legs more than they did if they didn't have that surgery. And for the first time, it showed that this paralysis wasn't fixed, but there was some hope. Unfortunately, 60% of the children did not have any improvement. So that led us to ask, well, if we could get a little improvement, maybe we could get more. This shows you a picture of this landmark paper that was published in the New England Journal of Medicine showing the effect that you would get if you operated on these babies before birth. So we asked that question. If we could get a little bit of improvement, could we, in fact, get more improvement or, in fact, repair the damage that was already done with using biologically active stem cells at the time of that fetal repair? So we went back to the drawing board to see what we could do. This involved the collaboration of stem cell scientists and bioengineers to work together in this new field of fetal regenerative medicine. Now, as a fetal surgeon, I have always been fascinated with the placenta. Here was this amazing organ that grew in just 9 months and then seemed to be done with its job. And we just discarded it after birth. It's formed from fetal tissue, and in fact, we used to diagnose certain genetic disorders in babies by doing what's called chorionic villus sampling. It's a way to get a little sample of tissue without injuring the fetus, but that has the same cells as a fetus to tell us what's going on. So we knew that we could access these important placental tissues before birth if needed. So we started studying these amazing cells that came from the placenta, and we learned, kind of not surprisingly, that they had unique properties. They were able to grow faster than ordinary mesenchymal stem cells that we used to get from the bone marrow. And if you think about it, it's kind of logical. They're younger. They're not quite embryonic stem cells, but they're not fully adult stem cells. So they act kind of like cells in between. They secrete an amazing amount of what we call sort of magic stem cell juice, the special paracrine secretion, the special stuff that helps cells grow and develop. And this is just one example here in the bottom that compared to bone marrow cells in the red, our placental stem cells secreted a lot more of this really important material called brain-derived neurotrophic factor. It's just something that helps nerve cells grow. So we thought we were onto something with these special cells. We went back to ask this question, okay, would this work? And it just so happens there's a really good model of spina bifida in fetal sheep. And if you look at these pictures, you can see that the human spina bifida looks really similar with that exposed spinal cord I talked about and the sheep spina bifida. And in fact, when the fetal lamb is born, it looks very similar to the way a human with spina bifida looks when they're born. That poor spinal cord is exposed to everything. And if you think about it for a minute as a human body, our brain and our spinal cords are the only organs that are completely encased in bone. They need to be protected. So we found a pair of pregnant sheep who had two twins, and we operated on both. And on one fetal lamb, we did our experiment with the stem cells and we repaired the defect. And in the other fetal lamb, we repaired the defect just with the regular material with no cells. And let me show you the miraculous and amazing results that we found. It's a little hard to believe. The lambs with stem cells are able to walk completely normally, whereas the lambs that don't have any stem cells are unable to walk at all. Again, you can see that that lamb with stem cells is almost walking normally. So this was so amazing we could hardly believe it. So we went back and did it again. We treated more lambs with stem cells, and we kept finding the same thing over and over, that the lambs that got the stem cells were able to walk, and the ones that did not were unable to walk. So for the first time, it looked like we actually had the possibility of a cure. So it turns out that bulldogs also get spina bifida. We were really surprised. You don't hear about it very often, but it turns out that when baby bulldogs are born with spina bifida, there are some rescue centers that will take care of these bulldogs. And interestingly, they look very similar, again, to human babies who are born with spina bifida. Those back legs below the area of the spinal cord lesion are paralyzed or partially paralyzed and can't move. And when they get older, just like children with spina bifida need wheelchairs because they can't support their weight, they even make bulldog wheelchairs as well. And if you look at the MRI studies, you also see that there's very similar findings in the human spinal cord up at the top and the bulldog spinal cord underneath it. So then we did the same thing we started to treat some of these bulldogs. Now, these bulldogs are treated after birth because we still don't know how to do fetal surgery in bulldogs, but we wanted to see if maybe even those dogs could be helped. And as you can see here, this is Spanky. He's our first bulldog that we treated. When you see him walking around, he's a little unbalanced in the back, and he walks on the full part of his leg, his lower leg, which isn't quite normal. And he's a little unbalanced. But 8 weeks post-op, you see an improvement. Here's Spanky hopping around. He's more up on his toes and walking more like a normal bulldog. So with this information and this experience in these 2 large animals, we manufactured cells. We got help from CIRM to do the special testing that's required to get approval from the FDA. And we are happy to report that we have approval and that our plan is to start testing this amazing cell therapy in human beings this January. We are going to do the same operation that we did and that we currently do for babies who are diagnosed with spina bifida before birth. But this time, when we repair the defect, we're going to repair the defect with a patch that contains the stem cells that we have previously manufactured from the placenta. And we're very excited that for the first time, we might be able to not just prevent further damage, but in fact, repair the damage that has already occurred and prevent paralysis in these kids. Wouldn't that be amazing? We're pretty excited. We think we're onto something special. I just want to thank all of the people who've been working on this over the last 10 years with the support of CIRM and other agencies, and we can't wait to share our results, hopefully sometime in the next year. Thank you so much for the opportunity to speak with you today, and I'd be delighted to answer questions.